Now we are going to move on to our new method called the substitution method. Now this method is going to be a lot more algebraic in that we are going to be not using a graph to solve it, but we're actually going to be solving equations to solve it. And so you'll see quite a bit of solving equation steps within this method. And this might take a few problems to practice to kind of get the hang of it, but then it kind of repeats the same method when you get to problems like this. So let's go ahead and read the problem. Mr. Swigum spent $12 at McDonald's. He bought 5 items total, some Big Macs and some Filet-O-Fish sandwiches. The Big Macs cost $3 each and the Filet-O-Fish sandwiches cost $2 each. How many of each sandwich did Mr. S buy? Shout out to Lucas on this. I was reading some of the getting to know you sheets and I noticed that his picture of what makes him happy is a Big Mac, and that certainly also makes me happy. So something that we can agree upon there. Okay, so if X stands for the number of Big Macs and Y stands for the number of Filet-O-Fish sandwiches, the two equations are X plus Y equals 5 because he bought 5 items total. So all the Big Macs plus all the Filet-O-Fish equals 5. And then the second one should look a little bit familiar. We've done some problems like this. It's $3 per Big Mac and $2 per Filet-O-Fish sandwich. And he spent a total of $12. So this one's kind of the money equation. This one is the total amount of items purchased equation. And so we want to figure out how many of each sandwich he bought, or I bought, that would satisfy both those equations. That would be 5 total items and also 12 total dollars. So we could solve this by graphing. It'd be pretty fast, and we'll actually continue to do that to check our answers. But we're going to talk about a new method that's called the substitution method. All right. So here's how the substitution method works. We need one of the variables to be by itself. Right? We need one of the equations to have one of the variables solved for by itself. So if needed, solve for a variable first. In other words, get a variable by itself. Notice neither one of these equations are in, for instance, y equals mx plus b form, or even have x by itself. They're both in standard form. And so I'm actually going to take this first equation and solve it for y. So I'm going to subtract that x over to the other side of the equation so that I can cancel it out from the left side, and I have y equals 5 minus x then. All right, so once I have that, and for this method to work, you are going to need to get one of the equations into either a y equals or even an x equals, because we're going to then look at the fact that, okay, these two things, the y and the 5 minus x, are equal to each other. That's what an equation is. It's just an equality statement, right? So these are equal to each other. Both sides of the equation are equal to each other. So we can substitute one for the other and solve. What I mean by that is, let's say you had like a $20 bill and you needed change for that. So you went, I don't know, at the convenience store or wherever, maybe the bank, and said, I need change for this 20. What they would give you is an equivalent amount of money, but maybe in some $1 bills, maybe they give you 20 $1 bills, maybe you need 4 $5 bills, maybe a couple $10 bills, but they'll trade you out something that's equivalent to that $20 bill. Well, think of the y kind of like the $20 bill, and think of the 5 minus x as like 4 $5 bills. All right. You can trade one out for the other. They are equal to each other. All right. So that's, I guess, the analogy that I'm going to kind of use here. I don't know if that works for you or not, but that's what the equal sign means. It means that we can take one and we can trade it out for the other. So since y is equal to 5 minus x, what we're going to do, and what I'd like you to do, is circle the 5 minus x part and we're going to draw an arrow over to the other equation, and we're going to trade it out for the y. Since y is equal to that, it's kind of like trading out the $4 $5 bills for the $20 bill. We're going to trade it out. We're going to substitute it in. So this is the substitution step. Substitution step right here. And then we're going to rewrite that equation for the price. All right, so 3x plus 2, and then we're going to do the substitution for the y. Remember, we're substituting 5 minus x in place of the y. So we're rewriting that equation, but we're substituting that 5 minus x. Now that makes it look maybe a little bit more complicated, but what we just did is we got the equation so that x is the only variable. We don't have an x and a y anymore, we just have an x, which means that we can now solve it for x. And now it's a matter of, do you remember all of your solving steps? This is a linear equation, we're going to solve for x. How can we simplify and solve for x? First thing I'm going to do is we're going to simplify that number in front of the parentheses there with the distributive property, because it's 2 times 5 minus x, so we got to multiply that 2 times both terms inside the parentheses. So that simplifies to 3x plus, okay, so 2 times 5 is 10, and then 2 times a minus x will be a negative 2x, or minus 2x equals 12. All right, so we did that step. The second step, if you remember our solving, is we're going to combine some like terms together here. We notice that we have 2 x terms that we can kind of bring together here. They're on the same side of the equation, so we can combine them. So by combining them, I mean essentially add them together, 3x plus negative 2x. So 3x plus negative 2x, if I'm putting those together, or 3x minus 2x will just be a 1x. And then we still have the plus 10 equals 12. All right, so now this is starting to simplify pretty quickly. Now it comes down to just your undoing steps from both sides of the equation. So if we want to get x by itself, now we can go ahead and undo that adding of 10 by subtracting 10 from both sides. And luckily I just have that 1x, or just x, left on the left side of the equation, and then 12 minus 10 is 2. So now I have the x part of my solution. Remember, when we're solving a system, we need an x and a y. We need the point that they share. If we're graphing them, it would be a set of coordinates, an x value and a y value. So we still need the y value. Now remember, we had 2 equations over there, and one of the equations we kind of changed around so that we had y by itself. So I'm going to bring that equation back in from up here and just think about, okay, well, if we know y is equal to 5 minus x, and now we know that x is 2, we can now simply put in that 2 in place of x, and then we just do 5 minus 2, and we get y is equal to 3. And that actually makes sense, because looking at our original equations, we needed a set of x and y values that worked in both equations. In other words, we needed 5 total items, so now we have 2 plus 3, which is 5. And then if we put 2 in for x here and 3 in for y here, 3 times 2 is 6, 2 times 3 is also 6, and 6 plus 6 is 12. So if you put 3 in for y and 2 in for x, that works as well. So we found an xy pair that works in both equations, and therefore 2, 3 is our solution. So let's just clarify what that means. So the solution is 2, 3, in other words, x value of 2 and a y value of 3. So what does that mean for Big Macs and filet of fish? So Mr. S bought 2 Big Macs, because the Big Macs were the x value, and 3 filet o fish sandwiches, because filet of fish sandwiches was the y value, for a total of 5 items. Oops, 5 items and a $12 cost or something like that. It added up to $12 and it was a total of 5 items.